Ó, eu vou, nesse momento, vou falar oi para você, né? Oi, boa tarde, legal que todo mundo está aqui, tanta gente, nossa. Eu vou falar nesse momento português ainda, mas devido ao meu parceiro aqui ao lado, eu preciso trocar para inglês depois, porque senão a gente vai ter uns problemas de alinhamento. Hoje a gente vai falar sobre aplicativo de criptomoeda, ok? E só avisando já, a gente tem uns stickers depois para pegar, uns adesivos, quem quiser, tá? E agora eu tenho que trocar para inglês. Isso vai ser meio complicado para mim agora, fazer o switch. So, right now, it's English right now. I think this is English mode, yeah. So we're talking about building a cross-platform cryptocurrency app. My name is Oliver, and this is Dylan. Let me see. Yeah, this is me. I'm a software craftsman at Dextra, developer at the Burst community. Living in Brazil since 2008. Doing capoeira since 2001, and this is what me brought to Brazil, actually. And I'm doing coding since 1992. So I think there are many people here that are much younger than that. They were even not born that time. So if you have my contacts here later on, we can change the contacts. And yeah, now it's time for Dylan.
Hello, everyone. I'm Dylan Butler. I manage the cloud front-end engineering team at Sony PlayStation. I'm also a developer at Burst. I've been developing for about 15 years. I'm also a licensed attorney in California. Today, we're going to talk to you about building a cross-platform cryptocurrency application. We're going to talk about some things like cross-platform monorepo app architecture. This architecture applies to things beyond a cryptocurrency wallet like you're going to learn about today. We're also going to talk about lessons learned while developing a shared NPM JavaScript library. We're going to talk about cryptocurrency app development in general and how it differs from standard client-server app architectures. Finally, we're going to talk about smart contracts and actually develop and deploy a live smart contract to the blockchain live.
So first of all, we need to talk a little bit about blockchain basics. This will be really a brief introduction on that, just to have a rough notion of the principal concept of that. I won't go inside the kinds of mining and any further steps. We are in this case not talking about a specific blockchain technology right now. So first of all, it is like the name says, it's like a blockchain. It's a chain of blocks. So a block contains transactions. Each transactions carry some arbitrary data of limited length. So each of these blocks got identified by a hash, a validated block. So the validation is something like it's done by a peer-to-peer decentralized network. That means there are several servers, if you can say that, in a huge network that are working together and trying to come to a consensus saying that this is the valid block for my blockchain. So inside that network, we have some, in certain blockchain technology, we have miners that are generating the hashes for the payload, and then we have the nodes itself that validates the hashes, and when they conclude that when the majority concludes that this is the valid block, then it will be connected to a chain. So each hash is combined with the content of a prior block. This means that when some of the blocks is going to be modified, then all the hashes since that block to the end of the chain will be invalidated. And this is what it makes actually immutable. So we have a huge immutable chain or list of data. And this is good for, we have some use case for that for like transaction records or as a ledgers. Then we can store historical data in that. So the most easy way to understand that could be like transactions for accounts. Banking accounts is nothing more like a transaction record. So most famous use case is cryptocurrency. Though these icons you see here, there are about a few selected out of all the cryptocurrencies we have over there. There are more than 2,000 cryptocurrencies listed. Many of them are just copycats of others. Others are much more interesting. Every species of cryptocurrency has kind of something new, different. There's this huge mess. And yeah, we are part of that mess. So we are working on a species called Burstcoin. And
so today you're going to hear about Burstcoin and Bitcoin. So what's the difference? The big difference is the consensus protocol. Burstcoin uses a consensus protocol called proof of capacity, which is essentially pre-computed nonces or hashes that are stored on the hard drive and then just retrieved later during mining. This results in an incredible gain in energy efficiency compared to Bitcoin. These are some outdated numbers, but it just gives you a sense of the disparity in efficiency in Bitcoin versus Burst. Burstcoin also has faster transactions due to a faster block time. And Burst has smart contract capabilities, Turing-proof smart contracts, as well as other features like an asset marketplace and crowdfunding capabilities. Finally, here's a timeline of the Burst community. We're just going to touch on this real quick. It was founded in 2014 by an anonymous developer, and then since then it's been community-driven. So it's had several development teams take over, and currently the Burst Apps team, which is our team, manages the Burstcoin GitHub repo. We work together alongside a marketing team called the Burst Marketing Fund. Here they are. And here's the Burst Apps team. These are the guys that we've been working with over the past year. So how did you get started, Oliver?
Well, when I got into the cryptocurrency, times were different. So the famous hit at that time was Despacito, which was in June 2015. And even the Bitcoin price was different. So if somebody of you is dealing with that, this is kind of the moment when I would buy today Bitcoin. But that's okay. You see that the history shows that they're going up the prices exponentially, almost. So BTC was gaining traction at that time, and I asked myself, what would I do? What would I do if I can go in? If I can go back in time? Well, so I jumped into 2010 or even 9 and start mining Bitcoin. So, but it was late. In 2017, it was not viable for me anymore to enter the mining for Bitcoin because it was already professionalized. And there was a huge industry of mining. And so that was the moment when I heard about hard drive mining. This is essentially what said that we store the hashes on a hard drive and instead of computing them real time. And I was immediately interested and I started to build up a huge rig and I tested out mining. So I started with that mining stuff and I figured out really fast that it could be much more user-friendly. It was like tools by techies for techies. And it was like hacking the console, making calculations and going on there. So my first contribution was kind of a tool that tried to simplify the process. It was like making some calculations on top of my hard drives and starting to make a kind of automated process of plotting, such that I can go out of my house because it is a long-term process and it started like doing that. Later on I started working on other tools. Most of them never made it in production. And still mining all this time. So, and how got you started, Dylan?
I got started in a kind of a similar way. So I was interested in cryptocurrencies. It was about 2017 as well, like most other people got in around that time. And I wanted to help. I thought if I could just apply my skills as a software developer, maybe I could help. And I saw some opportunity to work with really smart people, have an impact, and maybe make some coin. So I built a few small Burst tools, nothing big. But something was preventing mass adoption. Getting a local wallet set up was painful. Also, the Burst wallet was not available on an iOS device, and I'm an iOS user, so that made me sad. If I couldn't use it, my friends and family couldn't use it either. So it was clear what needed to be done. Burst needed an easy-to-use wallet. So I started working on a new wallet. It was a pretty popular idea, it turns out. A few weeks into the development, I got a message.
Hey man, I think you're really cool and we should build together an awesome new wallet. What do you think? Are you down?
This is how I felt inside, but I couldn't tell him that. So then we decided to get started.
So when we got together, we defined initially our project goals. One of the things was pretty clear is like it needs to be easy to use. As we are dealing with money, even crypto money, so it needs to be secure. It needs to be cross-platform. That means that we want to attempt modern web browsers, but also desktop and even mobile. So, and the beginning of each project, we need a name of that. So, and we call that Project Phoenix. Okay, this very cool name. And yeah, this is a part of the cryptocurrency wallet, and today it looks like that. So we were about half a year or 5 months working on that, and then released the first version, beta version, in May this year. But with all these ideas, so is it really live? Is it possible to do that what we want to do there? So we both have full-time jobs. Yeah. Time is very precious. I have a family. I need to balance my work life somewhere. And we started thinking on that. So code reuse is going to be crucial for us. And how we are going to organize all that stuff, that apps and libs. So we figured out that we have kind of apps, and we kind of have libs, and we need a desktop and all that. So the first thing we decided was, now, okay, just not to confuse how we enter the monorepo. The monorepo is not a monolith. Okay, monorepo is like we have one repository and we put it all inside there. So it worked pretty nice for us. I know there's some people there that don't share the same opinion on that, but it works pretty well for us. So we have a mobile section, we have a documentation part, we have some lib stuff, this is one of the crucial elements we have, and we have the Angular the web version, and yeah, and all the mobile, desktop, and NPM libs are published separately. So we decided to go with Angular, because we were aware that one day there will be other contributors for the project. And if we have a standardized opinionated framework, it will be much easier for everybody to go into the project. We decided to go with Electron because we want to have a cross-platform desktop application. And it's not like rebuilding everything twice and all that. So we said, okay, we put our Angular app into the Electron wrapper. And then for the other part, for the mobile part, we decided to go with React Native because, of course, we're already in a JavaScript world, so we can transfer some code or reusable code to these platforms pretty easily. So this is the entire architecture on a high level. So we have, on the lower part, we have the burst reference software, which is kind of abstraction layer of the true blockchain. So we interact with one of the nodes of the entire peer-to-peer network using Burst.js. So this is a publicly available library that abstracts away the API endpoints for the Burst reference software. And on top of Burst.js, we built the Angular app, which is then serving for all the web browsers. And then we put it inside an Electron. It's wrapped by Electron to serve this for the Windows, Mac OS, and Linux platforms. And on the other hand, we have React Native that uses part of the Burst.js also. So this is the entire architecture. And yeah, I think it's now time for you.
Yeah, so the architecture underpinning it is Burst.js, which, as we said, is our shared NPM library. And so in developing this NPM library, we wanted to share with you our lessons learned. So one of the things that we say you should do is follow semver. Semantic versioning is very helpful, especially when you're working with multiple packages inside of a single repo. Semver is going to make your life much easier. It's helped us add features. It's helped us detect whether or not features are supported. And it just helps us reason about our releases. Don't import from source. So if you're developing a package, it can be tempting to import your files from source. So this is package.json. And the reason why you don't want to do this is because this isn't what your end users are going to be using. Even though you have a monorepo and you can import from source, you shouldn't, because that's not what your end users are going to be using. Instead, you should import from the dist folder or the out folder. Whatever compiled, wherever you're placing your compiled assets, that's where you want your main file to be served to your end users. Do use Lerna for your scoped packages. Scoped packages are essentially the packages that begin with the @ symbol, like Angular or Burst.js. And you want to use Lerna for this because it makes creating new packages, distributing those or publishing those packages, as well as linking them together and installing them much simpler. And finally, document all the things. If they're reusable, you should definitely document it. You know, there's a saying that everything you expose in your API, whether it's intentional or not, people will eventually come to rely on. And so it's best that you document all the things and try your best to keep things up to date. In our case, we tried a lot of different things. We finally settled on JSDoc to Markdown, as well as TypeDoc. And the reason for this is our README files, right, our readme.md files contain very up-to-date documentation at all times, which is dynamically generated, as well as we maintain an online repo with our documentation, which is also always up to date, thanks to these two repos. So here's how you install it. Simple npm install burst.js core, as well as the other 2 packages that you might need. You can also use Yarn. We've also packaged it up so that you can use a script tag to install the minified bundles as well.
Oh, yeah, now it's hammer time. So we have prepared a small demo for the Burst.js library. Let me see how can do that. And this is like that one here. Going over that. Oh, this is a spoiler already. Okay. So I'm using here, I prepared a small demo here. If you haven't seen that before, this is Svelte. I'm abandoned React. Who knows me knows that I'm the React guy, but I'm not anymore. So what I want to show you is like a small application that is running. Let me see if that all is up right now. Yeah, okay, the server is already running. That means that I'm getting lost here. What's that?
Live demo.
Oh yeah, I don't go out there. And F11, yeah, it's complicated that.
There it is.
Yeah, there it is. I need to pick up, well, who moved that? So this is a small app. This is like checking my balance on a certain account on that. I just enter my account ID here. This is a very easy to remember one. And I'm checking the blockchain, and it's saying me that I have 16,000 burst on that address. Seems a lot? It isn't.
It's not a lot.
It's not a lot, yes. So what I want to show you is a little bit of code on that. So closing that, and closing that. I said closing that. So the interesting part is, this is something that I learned. We're working with a library, and we have really good support by VS Code, WebStorm for typed stuff. So what I do here is like I'm importing a Compose API. We use kind of an API builder pattern, and we put here inside the API settings. So once I compose the API, he returns me an API object, and it's pure JavaScript here, but in the backend, or like I have some meta information here. If I go there, he's showing me all my stuff I need, even with the type information. This makes, in terms of productivity, makes it much easier to work on that. So remember that this is Burst.js, which is just a library for other people to use. And if they have to consult every time the documentation to see how it's a secretly typed JavaScript object, so this is like of cumbersome and tedious, or you have all to record that. I'm not good at that. I'm an old guy already, and I have some problems in memorizing things. So I go in here, have the account, and they's going me all the methods I have already here, and I said, okay, I want to have to get account balance stuff. So go in here, and then I can just put the account ID on that. So this one is being imported, or it's like passed like a property from here. It's like, think of properties from React. And then I have some reactivity stuff here, which I will not go into inside that. It will just show you the entire flow. So Svelte gives me some nice feature, like I can just doing a wait, descriptive await for promise here. I'm fetching the balance. During that time, it's just like having this balance being executed and waiting, showing that one here. I'm going then, have the balance object, and then I need to convert this a little bit. So I have here the burst address stuff. The burst address stuff is already converted here. And each time the account ID would change, the reactivity operator here would change this immediately. So this is a kind of specialty from Svelte. If you're interested in that, this is another kind of stuff. But usually, this is how easy it is to interact with the blockchain information. So it's not with a blockchain directly, but it's like the blockchain information we can extract that easy way. And of course, we have other things like getting transactions and all of that. So yeah, this is the small demo. Going back to that one here. Oh,
we lose our slide.
What? They rebuilt. Complicated. This is normal, isn't it? Hammer time.
It's only about 160 slides, don't worry.
Yeah. Hammer time.
We're over halfway done.
There it is.
All right. Thank you.
Who's next? You.
You are.
No, yeah, it's me.
Yeah.
So modern software needs modern tooling. So we're professionals, and we use certain tools. And if you look at that, we have some badges. We like badges at GitHub. So we have code quality badges, we have other badges that show us some other metrics, all of that. And this is what we have done. So we put this inside a Travis CI pipeline. We built the app, you can see that on this image. We built the app, we bundle the Burst.js using rollup. We run Burst.js tests, we run Angular tests, we have some, not all is covered. And we even have a cron job that do a nightly release. So furthermore, we use Codicy for code quality inspection. It shows us some smelts, code smelts, and giving us some insights about eventually error-prone code. Even security issues, they're shown there, so we got an A grade here. I think we do pretty well. We have a code coverage. This is the code coverage for Burst.js library. It's about 93% right now, so we use CodeCov for that. And we use SNCC for vulnerability checks of our dependencies. This is something which is useful because we should be aware of that. So if there pop up some serious vulnerabilities, we immediately enter in contact with the maintainers of their dependency of the libraries and trying to figure out how long it will take that we can upgrade that. Okay, so drafting a release is as easy as tagging on Git and just doing a push. And this one line does almost everything for us. This is the builds. We have this one for this pushing, this tagging is for the deployment of the web and desktop app. It's not for the Burst.js library. So it builds and tests the Angular app. It builds each of the desktop targets. So we have Linux, Mac, and Windows. Then it just creates a draft release on GitHub such that we can make some regression testing on that. And then we add later, if that passes, we add additional information about the current release, like changelog and then we just click a button and say, okay, it's released right now. And it's even though that we use the GitHub repo and all the assets that are saved there to advise running desktop applications that there is a new version available such that can be downloaded automatically. So yeah, these are the uploads. I forgot that the uploads. It uploads the artifacts for the release, and now it stopped. Okay, yeah, and we have already the auto-published documentation. This is the type documentation for that on GitHub pages, so people can go there. But this one here is like, as this NPM library, this has to be published with Learner. So it's like Learner publish, like an NPM publish, and then it will just bumps all the versions for all the packages and the whole scoped package, and then it will be released on NPM. So yeah, we've got our stack.
So we've got our stack smothered in thick maple syrup and sprinkled with nice sugar. What do we do next? Let's build a crypto app. So first of all, logging into a crypto app is different, kind of like this Tesla. A client-server architecture requires trust. Trust in the server. Trust that the server doesn't look like this. Trust that the guy behind the server isn't going to do something malicious with your data. Trust that there's nobody manning the middling you and preventing or taking your data before it even gets to the server, or that they've compromised the server and they've been able to get your data from the server. Cryptocurrencies are a little bit different. Some cryptocurrencies are decentralized, and a nice feature of being decentralized is that they can be trustless. This means no username or password pair. Instead, you get a single passphrase that grants you absolute control over that account. If you have the passphrase, you have the account. Your passphrase is your account. So here's a function that we took from Burst.js that essentially generates master keys. It uses an elliptic curve cryptography to, given a passphrase, it's a string that you pass in. It generates a public key, a signed private key, and an agreement private key. And these are used for sending, receiving, and signing transactions. Again, your passphrase is your account. This is a function that, given a public key, which can be derived from a passphrase, can derive an account ID. So if you give me a passphrase, I can give you your public key as well as your account ID. So your account ID is derived from your passphrase as well. So you never actually log in to a crypto app. Instead, you're just proving that the public key to the access you're requesting derives from the passphrase that you provided. This means there's no calls to the server. It's just pure JavaScript. And let's talk about sending a transaction for a second. So what do you need to make a transaction? Well, you need to have a sufficient balance in your account. You can't send money if you don't have money. Secondly, you need to have a correct passphrase to the account with the money you're trying to send from. You need a sender. This is the account that you're sending. This is the passphrase, right? The passphrase and the account should derive one another. You also need a recipient. Who are you trying to send the money to? And then an amount. How much are you trying to send, right? And finally, for a lot of cryptos, there's a fee involved. And this fee goes to the miners. This is the incentive to keep the network operational. And then if we have those ingredients, we can make a transaction. So here's what a typical transaction call might look like. This is also taken straight from Burst.js. So you would call send amount, and you would pass in these parameters that we just walked over. You can even attach a message, like in this case, if you want to buy us a beer after this, you can use Burst.js to send us some Burst. That'd be great. And so how do we send the transaction? Well, it basically takes part in 3 steps. Number one is you send an unsigned transaction to the blockchain, which generates some unsigned transaction bytes. And then locally, we're going to take that unsigned transaction and we're going to sign it. So we never actually send your private key over the wire. Instead, we send everything but the private key. Then the server sends back an unsigned transaction. We sign it locally and then broadcast that signed transaction out to the peer-to-peer network. So here's the function that signs and broadcasts a transaction. So given an unsigned transaction and a service, which is configured to hit whatever node you want it to hit, we're going to generate a signature using your sender's private key, and then we're going to broadcast that transaction finally at the very bottom there. This is what the generate signature function looks like for those who are really interested, just to show you that this is just cryptography under the hood. It's all client-side. It's all right there. You can inspect it. You can walk through it. There's no black magic. And then finally, we broadcast that transaction to the peers, so that's what this function looks like. It's literally just calling an API method called broadcast transaction and attaching some signed transaction bytes. Once received, the peers will tell their peers, and their peers will tell their peers, and so forth. In this example, the miners put the transactions to the block. So in this example, we've got the kittens represent the transactions, and the box at their end represents the block. The miners seal the block with a hash. The nodes validate that block, and then that cycle repeats for each block as the chain gets larger and larger.
So far this was all the part of that what we did inside what we considered inside our application, our wallet. So crucial is this login and transaction signing part, and it was kind of difficult for me to understand initially that I have to sign something and I never will use a password. It's like a password which is already my account. This is a kind of concept. This changes a little bit my mind about that. So going now to the other section, this like the smart contract stuff. We don't use smart contracts yet in the wallet. Maybe in the future we have some use case. We don't know that right now. But smart contracts is an essential part in the crypto world. There are a few blockchain technologies out there that support them. For example, Ethereum, the most famous one, but also Burstcoin, which was in fact one of the first that supported kind of automated transaction, or we call this smart contracts. So what is a smart contract? Remember when I said that we have a block, inside the block there are transactions, and transactions carry arbitrary data of limited length. So what if that code or that data turns into something executable code? So there must be kind of a virtual machine or machine that executes a certain code of that. And yes, it's possible to do that. Think a little bit further. What does it mean? If I have a block sealed in my blockchain and I have data there inside, and assuming that that data is executable, that means that I cannot change that data anymore, or that code. That means that my code is, or my program is written into stone, and it turns like law. This is immutable. You cannot change this anymore. And this is something that is very interesting. If you have one code and you had agreed upon some certain code between 1, 2, 3, 4 parties, and you can say, okay, under certain conditions, I want to make a transaction. Like, okay, when this date is hit, then I want to transact that amount to you. This is a very interesting scenario. So code turns into law. This is like thinking of that. A blockchain is a single source of truth. We have a distributed list of data, like think a little bit of a database, and this is like static data. We can extract the data and all of that. But if we add smart contracts, so then we bring reactivity into all this entire system, because we can say that our machine is just checking out that there are some certain transactions are being done. This could be my trigger, and then I will dispatch other events on that. So this is the kind of reactivity we can gain with this kind of technology, smart contracts. This means, in fact, that we can do automated transactions, and we can do them trustless. So I mentioned that we don't have any authority, we don't need an authority being involved in that checks the execution of certain agreements. So interesting use case could be gaming, like in-gaming purchasing, selling items, making a marketplace inside the game using blockchain technology together with smart contracts. Ownership, you can transfer properties, may it be virtual or real physical ownership. If we are able, for example, to express some kind of real estate property in our blockchain, where it would be easy to do or to realize, to transfer the ownership upon certain payment. Imagine I have like kind of a document that proves that I'm the owner of that property here, and it's just like, I'm just like transferring that when somebody paid amount for me, it's like selling that. This would mean that we don't need any cartorio anymore. Imagine that, a world without cartorio. So, and another use case could be supply chain. Supply chain, this because we can track all the pieces that be assembled together, that we have our final product. And we can even include in that supply chain stuff kind of automated payments. For example, if some pieces or some part of my entire supply chain leaves a certain location like a port, then I can pay the guy who was responsible for the shipping and all of that. So there are very intense researches on that area to see how we can use that kind of technology. So in Burst, we have smart contracts written in Java. This is a pretty new feature we have. We had it, we use Java. This will be compiled to a certain machine code. And then it will be, we test it a little bit. We have kind of emulate test, and then we can publish it to the blockchain. When you publish that to the blockchain, then it's like I'm publishing it to anywhere, because we have the nodes spread all over the world. This is something what I consider like serverless. It's not that serverless of Amazon. It is Amazon server, okay? This is true serverless. It's triggered on each transaction. So we have this trigger cell that can, under certain conditions, I can dispatch or do something on that. It eventually executes. I said it's eventually, because it's not all that shine and bright, that world what I'm describing here. We have some drawbacks. So we have execution costs. For some reasons, kind of spamming and so on, we have costs for executing our code. That means that I have to pay in that cryptocurrency on that. We have limited space for code, and this is a hard constraint. There's like, I know the numbers in Burst is like, I have 2,560 bytes for my code. This is the maximum I have today, okay? And we have another thing, we talked a little bit about that, this is called block time. So the block time is the time when the next block is being released. So because it's work involved on that, so we have the miners who have to verify or generate the hashes, and then it must be verified and that. And many blockchains have a kind of block time. That means that, for example, we release every 4 minutes, in average, a block. Bitcoin, just for comparison, it's about every 10 minutes. So this is not really good for fast actions. It's not real time, but certain scenarios allow that. Okay. So finally, there's another hammer time, and I would like to show you, I hope this works, how to deploy a smart contract. So this is like live demo right now. I will deploy a contract. I try to deploy a contract in a test net. So we have the main net with our production net, and we have the test net. And then we'll use that. So let me see that going there. No, this we had already. That's it. Wow, what's happening here? Not sure. No, I'm going here over that. Okay. So it's a very, very, very simple contract I have here. So this is the Java code. This is like, this was a Brazilian colleague who made this compiler, just like Brazil. And shout outs to Joss. And this is the hello contract, though it extends the contract, and we have that method here. This is then we have a transaction received, and we want to just like send a message back to the one who sent some amount of money to us. And this is simply that. This is the entire contract here. We have, for emulating purposes, we have a kind of main point here. So when I start that, it will launch this kind of emulator. Hopefully I can open this a little bit more. Just like, I think it's pretty difficult to see. Sorry for that. Maybe I can do that like that. Well, yeah. So what I do right now, first, I create some accounts, okay? I have the contract creator. This is the one. And I will create the accounts like magically. This is the kind of airdrop. That means I created an address called creator, and then I will have another one which will be a user, and he will magically receive 100 bursts. Of course not. It's just like emulation. So the next thing is that I have to create the contract, and I choose the creator account for that, and this is my contract here. I call this hello contract. So there is a certain activation fee for that. So I can simulate any kind of amount here. This is still an emulate. And then I need to simulate the mining of a block. So I have to create the contract first. And it's said that this contract right now, it turns out into a transaction, which is put into the blockchain or being in the network, and it's about to be validated. As this is an emulator, I just can magically forge a block at my own will. So I have this contract created here, and then I go over and said, okay, I want to have that the user sends a certain amount, which is the amount of 1. Oh, well, I will make differently. I will just half burst, sending that. So it created another transaction. So there's another transaction. It's type is payment. I need to forge a block, and it happened nothing. This is what I expected. So, but if I send 1 burst and doing the same thing again, and like forging the block, then immediately there will be the contract that sends back to me, to the creator. Why to the creator? It's because the creator was, okay, I failed here. We can do this again. It's okay. No, it's okay. You understand that. Oh, yeah. So got back the message from that. Nice. So far, so good. I think my logic works. Very simple logic. Now I'm going to the interesting part. So this is a compiled version of my code. So Burst uses inside a kind of machine code, which is assembler code. This is this one like a formatted bytecode on the right side here. On the left side, in this small area here, we have the final bytecode that's being submitted to the blockchain. So I have some stuff here, like some descriptors. It's like hello from DevCamp, 5 minutes. Yeah, I choose a node to go there. I choose that one. Then I have a certain deadline amount here. That means when my transaction is not being processed within 1,440 minutes, this contract or this transaction will be disconsidered. So there's a kind of uncertainty on that, but this won't happen. So this is the cost I have to pay for my simple contract. So my execution costs for that contract is 4. So I need to keep that in mind. And I will put some activation costs here. That means that if I send 1 burst to that one, then it will be activated. There's one thing here, this is important, and this has to do with the passphrase stuff. So who is the creator? So and then I have to go there over and to pick up my passphrase. Can be revealed, there's no problem. It's a test net, it's not a true one. So just copy that. And I put this here inside. And now I'm publishing the code. And it works. Okay, this was published. This is not very spectacular. I think so. And now I can go here over there. This is our wallet. This is our nice wallet. Let me see. This is the demo account here. You sent 4 burst. Set that right now. And we need to wait a little bit if that transactions appear here. We can do another check in the meanwhile, see what's happening here. This is a small tool I wrote. This is kind of smart contracts inspector. So down in F5. Now it's not being deployed. It's being deployed. It will be processed right now. I can show that how it looks like the data of some smart contracts. We have some certain attributes here. Then is the data section. This is interesting because the smart contract has some certain state which is carrying. And this one here is kind of that can inspect some data. I know that, for example, that this decimal value here is account number. I don't know what this is. This seems like this current balance of that. And this is, I don't know what. So this is up to to the cryptic stuff. Okay, let's see if we have already the contract here. No, we don't have. What's happening here? Oh yeah, we can see in that transaction that there's a smart contract creation running. It's a minute ago. That means that now the anti-network, so the node received the transaction, and the network is now processing that. And in a few moments, it should turn from gray to black. That means that the contract will be available. And then it should appear in my small tool here, which is still not there. So, and this is, you can already see that we have a problem. This is like, it's not that fast that everybody thinks or may think. It needs its time until it works. So we have only two minutes left here. I can show you, I think it won't be possible that we can see the entire flow, like sending something like that. I have done this before, of course, being prepared for that. You can see something like the other test account I have here. A few hours ago, I sent it, for example, to another contract. This one here is a contract. I sent it some money to him, and he returned immediately. In the same moment, he returned a message to me, and the message was like, "Hello, DevCamp." You can see that here, and it's like the payment of a smart contract. That means this transaction of a smart contract. Yes, and this is usually how it works. Let me see if the contract is already here. No, it turns out to be deployed right now. So we can see that it should appear here. There it is. So the contract is here. But I think I will stop here because I know that the other transactions I will do, they won't do it within the time we have. There's just 1 minute left. So closing our presentation here. Thank you. Yeah, that's it.
Thank you.